how fast Arnold can run 100 meters.
Before that, let's take a look at the data for the male 100-meter sprint times. According to the central limit theorem, we know that this will follow a normal distribution and can be modeled by the curve as seen in the frame. To find the probability of running a certain speed, we just need to find the area underneath the curve at that point. For example, if we wanted to find the probability of running faster than 11 seconds at this point, then we would integrate from 10.5, the fastest time, to 11, and the area underneath would be equal to the probability. Therefore, this also means that if we integrated the entire function from 10.5 to the slowest time or the end of the function, the area under the curve would be equal to 1. The peak of the function, as you can see here, is also known as the expected value, or the mean. This is also the mode, which is basically the most frequent time run out of all the data collected in this function. We can find this value by integrating x times the entire function, and this would give us the expected value mean or mode. The mean or average is a very effective way at comparing a data point to see if it is below or above average. Okay, now that we know all this, let's see how fast Arnold can run. Before knowing Arnold's time and how it compares to the data, it is important to know the concept of standard deviation and mean. As stated before, mean is expected value, or the most frequent time run. However, standard deviation is a measure of the amount of variation of the values of a variable about its mean. A low standard deviation would mean that the data tends close to the mean, while a high standard deviation would show that the data is spread about a wider range. And this can be shown through the values of mu and sigma, which represent mean and standard deviation respectively. Anna's sprint time was 120 seconds, which is extremely slow. And we also know that the probability of Arnold running faster than 12 seconds is 0.000001, and the probability that she runs faster than 100 seconds is 0.4. If we don't know the mean and the standard deviation, then we can use a concept called the z-score. The z-score is a statistical measurement of a score's relationship to the mean in a group of scores. And from this, we can form two simultaneous equations in order to find the mean and the standard deviation. So, for example, if we use the area, which is 0.0001, as stated before, and we can find the z-score of Arnold's time. From this, if it's, say, 4, then it shows that Arnold's time is extremely above average than the average, which is around 11 seconds, which shows that she's an extremely slow runner. From this, we can see that Arnold ran 120 seconds, which puts her in the slowest 0.0000001% of men. She's 10 standard deviations away from the mean, which is very much on the slower side, so we suggest that she train a bit more before her next sprint.
Thanks for watching.